Hi, I'm Peter, and this is the 10th video in the Microbit Made Easy series from Engineering Wonder. In this video, I'm going to teach you how to use your input-output pins to control external components on your microbit. If you don't have a microbit, you can get one from the Engineering Wonder store at store.engineeringwonder.show. If you like this video or learned something from it, be sure to gently hit that like button. Subscribe to the channel so you don't miss anything. All right, let's get into it. What are the input-output pins on your microbit? You see those metal spaces down below? Those are the input-output pins. There's big ones labeled 0, 1, 2, and then there's the tiny little ones in between that are also input-output pins. To access those, it's best probably to have a breakout board, but we're going to use the big ones because you can use alligator clips to connect to those input-output pins. With these pins, we can expand what our microbit can do. We can add external lights, we can control motors, we can have different sensors that the microbit doesn't have and input that information into the microbit, or we can control things and output information using those pins. In the last video, I showed you how to turn on and off all your LEDs on your microbit by clapping. What if we could turn on and off this LED that's not even connected yet? We would use an input-output pin to control this LED. All right, let's first dive into the code of how we could do that, and then we'll go to the workbench and build the circuit. First, let's go to makecode.microbit.org. And let's go to our last project, clap lights. We're just going to use the project we already used and see if we can add on some functionality. We want access to our I/O pins, our input-output pins. So let's look over here and see what we have in our toolbox. I don't see anything that we can use here. Let's click on advanced. Oh, there they are, pins down here. So if you click on the pins toolbox, you'll see a bunch of blocks that we can use. Let's talk about the first two at the top. Digital read pin. So this will read information coming in from the pin, and it'll be a digital signal. And if you know how computers talk, they talk in a language called binary. And binary is either a 1 or a 0. It only understands two things, a 1 or a 0. It's either an electrical high signal, so it's giving a high signal of electricity, or a digital low signal, which is giving a low signal of electricity. So it will be either reading a 1 or a 0 coming from a pin. The digital write pin will be writing or sending information. It'll either be sending a 1 or a 0 because it's a digital signal. All digital signals are 1s or 0s, and 1s, remember, are high electricity and 0s are low electricity. So we want to send information, we want to send electricity, we want to our LED to turn it on, so we want the digital write pin block. And let's put that right underneath our show LEDs. And if you click here, you'll have a bunch of options of pins. Now, we are going to use our alligator clips, so we really only have access to pins 0, 1, and 2 for this. So let's just keep it on 0. And because we're turning on our LEDs, we want to send a 1, a high signal, to that pin, and that will turn the LED on. Let's go to the next if statement. We want to turn off the LED here, so let's grab the digital write pin and put it after the clear screen, and we'll keep it at 0. So it's going to send a low signal, a low electrical signal, and turn off the LED there. So let's test it out in our simulator. So here's our sound meter. When we clap, it turns on, and you'll notice over here the 0 has turned on. So it's sending a 1 or an electrical high signal. Now if we clap again, it's now sending a 0 or a low signal, and it will turn off that pin. High signal, low signal. Great, so we have our code. Let's download it to our microbit. And let's plug our microbit in to our computer. Click download. And let's find it. Here we go. Clap lights 2. This is the second one we made, and drag it on your microbit. It'll load onto your microbit. After it's done loading, you can unplug this, and I'm going to take this to my workbench and show you how to make the circuit. To make your circuit, grab your microbit and a power source, a couple alligator clips with pins on the end, a 180 ohm resistor, an LED, and a breadboard. A breadboard is a really useful tool when prototyping circuits. They consist of three main parts. The terminal rows, each row is connected by a conductor. The center divider that separates the terminal rows on each side so they are not connected by a conductor. Then the power rails, this is where you run your power to for your circuit. Each power rail column is connected by a conductor. Grab your breadboard and your LED. An LED has two pins, the anode, which is the long pin that will be connected to positive voltage or your 0 pin, and the short pin, which is the cathode, which will be connected to ground. Plug the pins of your LED into separate terminal rows on the same side of your breadboard. When using LEDs, you should always protect it with a current limiting resistor so you don't burn out your LEDs. If you don't have the correct resistor value, you can always go up a value, but never go down. I like to trim the leads up on my resistor to make them easier to put into the breadboard. Then connect one side of your resistor to the same terminal row that the cathode side of your LED is connected to, and plug the other side of your resistor into an empty terminal row, like this. Then plug in your black alligator clip into the same terminal row that your resistor is in, like this. Then plug your red alligator clip into the same terminal row that your anode pin on your LED is plugged into, like this. Then connect your black alligator clip to the ground pin on your microbit. Then connect your red alligator clip to the 0 pin on your microbit. Connect your microbit to power and you are ready to start testing. We just made a project using one of our input-output pins as an output. Now let's make a project to use that same pin as an input. I've been investigating what objects are electrically conductive and which aren't. So it would be interesting if we could turn our microbit into a device that could detect if a material is electrically conductive or not. So is it a conductor or is it an insulator? Let's try writing some code to do that. Let's create a new project and we'll call this Conductivity Tester. Create. We're going to use our pins to test material to see if it's conductive or not. So how could we do that? I have an idea. A button is a mechanism that keeps two electrically conductive materials apart, and when it's pressed, they connect together and it allows electricity to flow through, and a computer can sense that and do something when that button is pressed. A button is an input because we're giving information to the microbit. So let's go into the input toolbox and see what we have. Let's see, on pin, oh look at this, this is interesting, on pin pressed. So we can do the same thing that we've been doing with the buttons but with a pin. So and it gives us our pins here, pins 0, 1, and 2. So how does this work? When pin 0 is pressed, it will sense and run code inside. What happens if it's not pressed? Well, nothing will happen. And we want something to happen. We want the microbit to tell us that it is not conductive as well as it's conductive. So we have multiple outcomes. We have two conditions that we need to meet, connected and not connected. So this is only connected. So if we have more than one condition, we're going to need an if statement. So go ahead into logic and grab an if statement, and we want to check this constantly, forever. So if something is true or false, then do this. What do we want it to do? Let's go back into our input here, and I saw another block here, this one. If we put this in here, let's go through our logic here. In the forever loop, it's going to constantly be checking if pin 0 is pressed. If it is, it's going to do what's inside here. If it's not, for everything else, it'll run this code in here. So when it is pressed, we want some sort of icon to show on our LED, an output to show that it is connected. You could put any icon in there or come up with your own. Let's do a smiley face. I like smiley faces. It would be nice to have some sort of audible confirmation that it's connected. So let's go into music and grab a play tone and put that in that if statement, and let's choose, I like a higher note here. There, that'll work. And for everything else, we want to have the frown face showing. We're running into a problem we ran into before. Pin 0 is used by default for audio through your headphones, but we are using it as a button, so it's being used for two things, and it could get confusing, and our program might not work right. So we could actually change this to pin 1 if we wanted, if we were using headphones, or we could disable audio on pin 0. Let's do that. Let's go into our pins section in our toolbox and go down to set audio pin enabled false and put that in our on start block. And that should, yep, it is going to disable headphones out of pin 0. I think it's time to test our code. Grab your microbit, connect it to your computer, and download your code and drag that onto your microbit. Once the code is done loading on your microbit, you can leave it plugged in to test it or unplug it. I'm going to take it to my bench and go test it over there. You're going to need your microbit, a power source, 2 alligator clips, preferably black and red, and a bunch of stuff to test to see if it's conductive. I'm just grabbing a bunch of stuff off my workbench. Connect the black alligator clip to the ground pin on your microbit and the red alligator clip to the 0 pin on your microbit. Then connect your microbit to power and you are ready to test. Let's test it to see if it works by touching the alligator clips together. Yippee, it works! Let's try our first conductivity test. Let's try the metal part of my screwdriver. Hey, metal is conductive. Let's try the plastic handle on my screwdriver. No, it does not conduct electricity. Let's try the rubber head of this mallet. No, it does not conduct electricity. How about the wood handle? No, it does not conduct electricity. How about the cap and the bottle of the rubber cement? Let's try the cap. I think it's metal. Yes, it does conduct electricity. How about the bottle? No, it does not conduct electricity. How about this mechanical pencil? No, it does not conduct electricity. But what about the pencil lead inside? Pencil lead is graphite. Let's see if graphite's conductive. Hey, graphite is conductive. That project I probably have the most fun with because I walk around my house with this thing testing objects to see if they're electrically conductive or not. And you should too. It's a fun experiment. You can see what's conductive, what isn't, and you might be surprised sometimes about what is and what isn't conductive. Now you know how to use your input-output pins as both an input and an output. In the next video, I'm going to teach you how to use the wireless radios in your microbit so you can send information invisibly over radio waves to other microbits.